In the previous module, we were talking about shapes, which are flat, two-dimensional objects. For this module, I want to show you how to turn those shapes into the illusion of form. So when we talk about three-dimensional form in reference to drawing, we are not talking about actual form, which would be something like this, where I can turn it over in my hand. So this is 3 dimensions in real life, right? 3 dimensions on a drawing or a flat picture plane is always going to be the illusion of 3 dimensions. And so there's a couple of strategies for creating the illusion of 3 dimensions, right? So let's start off with a circle as an example. And remember, all of these examples that we use, basic forms, are for simplicity's sake. The same exact concepts apply to anything that's more complicated. So this is flat, right? So there's a space within the circle, which is created by a contour line, and there's a space outside of the circle. The circle itself, this enclosed space, this is called the positive space because it's the figure. And this is the negative space because it's the ground. This is the thing that's being created in the void of the negative space, okay? And it's just flat. One simple strategy to start making a flat two-dimensional shape look like it has the illusion of three dimensions is to apply a cross-section. Okay, so a cross-section is basically if you slice a form in half, it's going to be the shape of the slice. So this is a three-dimensional form, right? A cross-section of this three-dimensional form is basically going to be if I slice it in half. If I slice it in half, the cross-section is going to be this shape, right? So the cross-section has a shape. A cross-section in perspective, it still has a shape, but in perspective, it's more oblong, right? So it changes. If you look at the distance between this edge and this edge when you're looking straight on, it's longer than if you're looking at the same edge here with this in slightly tilted in perspective. Okay, so applying that to a drawing, right? So pretend like this is an apple, and I'll just go ahead and create it into an apple. This would be the cross section. So if I wanted to create this into an apple, I start off with a sphere because that's an apple most resembles a sphere. And then I can draw, like, say the apple is, I already have this cross section, so I'm just going to make the stem here, right? And then I can just cut into the edges, and then an apple isn't quite like a sphere. It depends on what brand it is, and then you can add the lumps down at the bottom and change the contours afterwards, right? But then the cross section this way is going to be a different shape than it is if you take the cross section from the top versus from the side. So I'm gonna cut it from the side so you see, because this is very round. When I cut it on the side, that cross section is going to look like a circle. Okay, so you see that? It looks like a circle. But if you were to look at it in perspective, it's an ellipse. In perspective, the edge that you see here and here in perspective are much closer together when you're drawing them. Okay, so cross section is one strategy. The next strategy is cross contour. Remember, well, we didn't cover line, but a contour line is basically just a line. When I say contour line, I'm talking about an outline or a line that defines edges. So if I were to draw this apple slice, the contour lines would be the edges that I can see. So this is a contour line drawing of this apple section. Okay, so cross contour is going to be, let's use a sphere as an example, is going to be just a series of cross sections, really. So when you're talking about a circle, you have the latitude lines, right, that go all the way up to the top, and those are just a series of ellipses. But notice how I'm not laying down the back. This is an ellipse. Okay, when I'm drawing a cross section on a sphere, I'm not laying down the back part of the ellipse. I'm still moving my hand in an elliptical direction. I'm just not laying down those back lines. Okay, so a cross contour defines the surface. Okay, so if an apple is round, right? So a cross contour is going to be round, and it defines the behavior of the surface of an object, right? So you can have the latitude cross sections or the longitude cross sections, which are also ellipses. I just don't draw the back part of them. Okay, so do you see the difference between, I'm going to draw those over. Do you see the difference between this circle and this is a circle that has cross contours applied, and it looks like it has 3 dimensions. So let's do that again. Let's put those side by side. They're both circles. Now just stare at that for a second. You see how this one seems to pop up off the page? Obviously not, it's flat. Okay, so this is called cross contour. And the third strategy for creating the illusion of 3 dimensions is value. Okay, so value usually is going to involve a light source, right? Well, I mean, it always involves a light source. When you're talking about a drawing, or if you're doing a drawing from your head, I'm not looking at a sphere that has a light source, then I make up the light source. So if, say, the light source is coming from this direction, right? The light hits the object up to here. And where the terminator happens, the light is hitting up to here. Where the terminator happens follows along with the same kind of behavior as a cross contour. It's not going to be a sharp line, but it's going to be a value, right? Where the light ends at the terminator, right below the terminator, is your core shadow. And that's going to be the darkest. Up here, these are going to be midtones because it's still receiving light. It's not receiving direct light. The most direct light is happening here, right? Okay, so the most direct light, remember on your value scale how you use an H pencil to get the lighter values. So where you're going to do direct light, you want to use an H pencil. And I'm not pressing hard. It's just very light. And as the ball, the sphere, rounds towards the terminator, it gets just a little bit darker, but not dark. It's not, these are the high key values. They're high key because they're in the light. Okay, so when you're thinking of high key values, think of values that are in the light. The values below the terminator are also going to be darker, but they're not going to be as dark as the terminator. The terminator is going to be the darkest shadow besides the cast shadow, which we'll get into in a minute. So on the form, these form shadows that I'm drawing, so this is the light section of the sphere, and this is the shadow section of the sphere down here, where the light is not directly on the object. Okay, and then now the final most significant, one of the most significant aspects of creating the illusions of 3 dimensions is a cast shadow. Unless this ball is floating in the air and you don't have a view of the ground or any surfaces near it, then it's always going to have a cast shadow. So let's say this is on a surface. I'm going to put a line back here to represent a surface. So let's say it's on a table. Well, it's gonna, the light's coming from here, so the cast shadow is gonna cast over here. And it's gonna be the shape of some sort of ellipse. Okay, and then the cast shadow is darkest right in the crevice of the object. This is called the occlusion shadow right here. The darkest part right in the crevice is the occlusion shadow. And the cast shadow is darker than the form shadow, than most of the form shadow, because there's no light hitting where the cast shadow is at. The object is blocking the light. But there's a lot of light, there's a lot of ambient light that's bouncing off of surrounding surfaces, right? So when the light hits the surface, it bounces back up to the bottom of the ball. So it bounces everywhere the light is hitting. See, the light hits all over. It bounces back up to the bottom part of the ball, the part of the ball that is pointed towards the planar surface, right? And the top of the ball is pointed towards the light. The part of the ball that's not pointed towards the planar surface of the light is the terminator. That's why it's the darkest, right? And so you'll see that I've rendered it's a little bit lighter down here at the bottom. It's counterintuitive, but it's because light is hitting the surface and bouncing back up on the ball, and it's reflecting light. And then there's no light bouncing in the crevice. That's why the crevice is darker. And then the light that's bouncing all over everything else is causing this cast shadow to get just a little bit lighter as it gets towards the end of towards the end of the shadow. Okay, so you see the difference between this flat circle and this form. This also is a circle. It just has the illusion of form because I've created a shadow. And this is sort of like how the behavior of the surface dictates how the light is going to behave. So I have my cross contours like this, but let me redraw a circle with, it's the same thing, only I have, so say the axis of rotation is there. Well, in this case, if we're thinking about the light source as determining the axis of the cross contours, it would be there. And so the light is going to follow the behavior of the cross contour, because when the object's contours fall away from the light source, that's where the shadow happens.